Have you ever looked up at the night sky and wondered about the vastness of the universe? Or perhaps pondered the intricate dance of life within a single cell? What about the invisible forces that power our everyday devices, or the very elements that make up our bodies and the world around us? These profound questions, and our relentless pursuit of their answers, lie at the very heart of something fundamental to human progress: science. Today, we're embarking on a captivating journey into the world of science. We'll explore not just what science is, but how it works, its incredible breadth, its rich history of discovery, and its astonishing impact on every facet of our lives. Prepare to unravel the curiosity, the systematic inquiry, and the relentless quest for understanding that defines this extraordinary human endeavor. At its core, science is far more than just a collection of facts. It's a systematic way of understanding the natural and social world through observation and experimentation. The bedrock of this understanding is the scientific method, a cyclical process designed to minimize bias and maximize the reliability of our findings. It typically begins with an observation, sparking a question: why does this happen? From that question, we formulate a testable hypothesis, essentially an educated guess based on existing knowledge. This hypothesis is then put to the test through rigorous experimentation, where we carefully manipulate variables to isolate their effects. Imagine testing if increased sunlight promotes greater plant growth by varying light exposure for identical plants, keeping all other factors constant. After collecting and analyzing data, we determine if our results support or contradict our initial hypothesis. If the data supports it, great. If not, it's not a failure, but an opportunity to refine our hypothesis or formulate a new one, leading to further investigation. This iterative nature, observing, questioning, hypothesizing, experimenting, analyzing, and concluding, is what makes science so powerful, a continuous loop of learning, always open to new evidence and revised understanding. Science isn't a single, monolithic field, it's a magnificent tree with countless interconnected branches. Broadly, we categorize it into natural sciences, which delve into the physical world, and social sciences, which investigate human society. Natural sciences encompass disciplines like physics, studying matter and energy, chemistry, exploring the composition and reactions of matter, and biology, the study of life itself, from cells to ecosystems. Within natural sciences, we also find astronomy, peering into the cosmos, geology, unraveling Earth's history, and environmental science, focusing on planetary systems. The beauty lies in their synergy. Biological processes depend on chemistry, which relies on physics. Understanding climate change, for example, requires insights from physics, chemistry, biology, and geology, demonstrating how these fields constantly inform each other. Social sciences, on the other hand, explore human behavior and societal structures. This includes psychology, studying the mind, sociology, examining social interactions, economics, analyzing resources, and anthropology, exploring human culture. While distinct, these branches often employ similar rigorous, evidence-based methodologies as the natural sciences, seeking patterns and understanding within the complexities of human experience. Together, these diverse fields paint an increasingly comprehensive picture of our universe and ourselves. The story of science is the story of humanity's endless curiosity, stretching back millennia. While early inquiry existed in ancient civilizations, the modern scientific endeavor truly began to crystallize during the scientific revolution in the 16th and 17th centuries. Figures like Nicholas Copernicus challenged geocentric dogma with a heliocentric universe, a view later solidified by Galileo Galilei's telescopic observations. Isaac Newton then unveiled universal laws of motion and gravitation, providing a unified framework for understanding both celestial mechanics and terrestrial physics. In chemistry, Robert Boyle pioneered the experimental method, leading to modern chemical analysis, while Antoine Lavoisier established the law of conservation of mass, laying groundwork for quantitative chemistry. The 19th and 20th centuries brought an explosion of insight. Charles Darwin revolutionized biology with his theory of evolution by natural selection. Albert Einstein's theories of relativity reshaped our concepts of space, time, and gravity. The discovery of DNA's double helix unlocked secrets of heredity. From harnessing electricity to developing vaccines, understanding quantum mechanics, and venturing into space, each milestone built upon previous knowledge, demonstrating science as a cumulative and collaborative human achievement. This continuous process of building, challenging, and refining knowledge propels us forward. While theories like relativity might seem abstract, science permeates every aspect of our daily existence, often in ways we don't consciously register. Consider the smartphone in your pocket. Its capabilities, from its touch screen and GPS to its rapid processing power and wireless communication, are direct products of decades of scientific research across physics, material science, computer science, and engineering. The semiconductor chips at its heart are a testament to our understanding of quantum mechanics. Think about your health. Vaccines, antibiotics, MRI machines, and life-saving surgical techniques are all triumphs of biological and medical science. The food we eat benefits from agricultural science, which has revolutionized crop yields and nutritional content. Our modern infrastructure, the bridges we cross, the buildings we inhabit, the clean water we drink, is built on principles derived from material science, civil engineering, and chemistry. Even the internet, which allows you to watch this video, relies on complex networks born from computer science and electrical engineering, with data traveling at the speed of light through fiber optic cables, a technology enabled by our understanding of optics. From weather forecasts, powered by atmospheric science, to renewable energy technologies like solar panels, which draw on physics and material science, science isn't confined to laboratories. It's the invisible architect of our modern world, constantly improving our quality of life and expanding our possibilities. As we stand at the precipice of new discoveries, the future of science is as exciting as it is challenging. Scientists today are grappling with some of humanity's most pressing global issues. Climate change, for instance, requires concerted efforts from environmental science, physics, chemistry, and engineering to develop sustainable energy solutions and mitigate its impact. The quest for clean, abundant energy through nuclear fusion or advanced renewables continues to be a monumental scientific and engineering challenge. In healthcare, personalized medicine, driven by genomics and artificial intelligence, promises to revolutionize how we treat diseases, tailoring therapies to an individual's unique genetic makeup. The intricate workings of the human brain remain one of the greatest biological mysteries, with neuroscience pushing the boundaries of understanding consciousness and neurological disorders. And beyond Earth, the dream of space colonization and the search for extraterrestrial life continue to inspire groundbreaking advancements in astrophysics and astrobiology. Artificial intelligence itself, building on computer science, is rapidly transforming industries and raising profound questions about the nature of intelligence. These frontiers also bring ethical considerations and the need for responsible innovation. Science is not just about finding answers, it's about asking better questions, embracing uncertainty, and collaborating globally to address complex problems. The journey of scientific discovery is endless, constantly redefining the boundaries of what's possible and what it means to be human in an ever-evolving universe. So, whether it's decoding the mysteries of the cosmos, unraveling the complexities of life, or building the technologies of tomorrow, science remains our most powerful tool for understanding and shaping our world. It's a testament to human curiosity, ingenuity, and our shared desire to know. If you found this journey through the world of science enlightening, please give this video a thumbs up, share it with fellow curious minds, and subscribe to our channel for more explorations into the fascinating subjects that shape our understanding of existence. What scientific field fascinates you the most? Let us know in the comments below.